case for the others they can have the recording. Can start.
Hello, everybody. Welcome to today's workshop on scale and descriptive statistics. Can all of you hear us? Can all of you hear me?
Yes, we can, Dr. Abhijit.
Yes,
Thank you,
we
Varna.
can, Dr. Abhijit.
Thank you, Dr. Mania. Thank you. Nice to see you all. And hearty welcome to this particular workshop. This workshop is extremely important for all of us, including me, to refresh our knowledge in statistics and especially to refresh our knowledge on applications of quantitative techniques. Because, in DBA, we prefer students to follow the mixed methods where you have a blend of qualitative and quantitative techniques, okay, research. So it is very important I know some of you or many of you are conversant with the statistics, but some of us need brush up, or it is better to get it, get our knowledge again rechecked, whether we are thinking correctly or not, even though we know. So this is the opportunity what Dr. Shankar has kindly consented to come up with. And he has already taken part 1 of these particular things. And you see how, how much importance we are giving. We are offering this free workshop and Dr. Shankar and the faculties, they are coming forward and they are delivering this for this workshop or any other workshop if you do that. And especially this workshop, we are divided into 2 because part 1, part 2, so that you can digest very easily and you can apply those things over there. So you have to be, if you have any query, you can come through chat box and we will be answering your query as well. Dr. Shankar will definitely help you to understand it better. So with this, I just hand over to Dr. Shankar for starting the session of the day. Okay. All the very best. Have a nice time here. Thank you, Dr. Shankar. Over to you.
Thank you, Dr. Abhijit, for the intro. So last time we have seen what is descriptive statistics. So we'll carry forward from there, but I'll try and make it very, very practical oriented, because that's the need of the hour. Because I see most of the times the students or even the faculty ourselves, we are not sure of what is required from data and how to look at it. So can you see the screen?
Yes, I can.
Yeah, okay.
I can, yeah.
Yes, thanks. So I just start from the place. Let's say you're doing a survey. Okay. So that's how we get the data. That's the primary data. And then we'll see how to do about and analyze it. So when you make a survey, generally you need to have a concern. So that's what we do here. Then we have the demographics. Okay. So we'd like to know what are the responses or respondents profile. So in case we can draw some inferences on that. So whatever is important, you need to do that. Okay. And at the same time, don't overdo it, because it'll be waste of time for you as well as for your respondent. And it's not nice. It's not ethical also. So what's required to be done is what you are doing. So generally you see that a Google form is a free flow and you can add on many respondents, whereas in some of the other like SurveyMonkey, you would have to probably pay. Okay, so these are the questions profile you can give. And then let's say you have your other questions like the Likert scale. So you fill it like this. Okay. And then get the link. So generally, so I just go quickly from here. So you can send it directly on mail, or you can get a link and you can copy and send it to others. Okay. So that's how you will collect your responses, and the responses will come here. For example, this shows around 68. Okay. So once I have this, let's say I want to analyze the data. So this is a primary data you have. Okay. So I can download this. So it comes as a CSV file. So when you look at a CSV file, it will look exactly like this. So you'll have the timestamp, you'll have the username, the questions, one after the other. Okay. So, so all this is the way it will come. So now I need to first check whether all the data is there, any missing data. So this you can actually ensure by doing some setting on your what do you call Google form itself. So you ensure that the participant is not allowed to go further without marking all the what do you call steps. So then you'll have less of missing data. Otherwise, you can have a lot of missing data. But still, the first stage is to after you collect the information, to see all the data has got in the right manner. Okay. So it starts from there. So let's say you have a data set like this. Okay, the same thing. So I'd like to see whether all the data is there. So I'll try to see which is the unique quantity in this, because you have all of this, you'll have a mix of this. So nothing seems to be unique except the email. Okay. In some data, it could be a customer ID, for example. So you'd like to see what is the uniqueness. Okay. So because the uniqueness can be tested by removing the duplicates. So we have the option on, let's say I have also a column which is a respondent ID, which has been given dedicated to all. Okay. So I can across the email give a ID number, and then I would like to see whether there's any duplicate given by chance, or even I can check with your email itself. But then we need to code, because Excel is can deal with numbers and not with the text. Okay, so once you collect it, let's say a respondent ID number which is given, so we'd like to see whether there's any duplicate, as in, so you can go to data. So you have data, okay, and remove duplicates. This is the option I will use, and that's exactly what I put here. So if you look closely, I hope the screen is clear. Someone can confirm. Simi, can the screen is the
Yes,
screen
Dr.
clear?
Shankar.
Yeah.
It is
Yes.
clear,
Thank you.
but it is very, very
I
tiny.
think if you can enlarge it little bit, Dr. Shankar, is it possible? Ah, that's good now.
No, this is only a snapshot. I'm showing you on the screen what to do. So
Okay.
basically, on the data, you have this option of removing the duplicates. So that's exactly what I've written here. Select the columns. Then when you say this, okay, so it can ask for the data. Okay.
Hmm.
So I can expand the section because I already marked the IDs there, and remove the duplicates. So automatically it will ask me what, and you can say, okay. So you'll get a confirmation that there are no duplicates. Okay. So that is one of the things you can do. The next thing is you can look at the missing value. So generally we use the concept of is blank. So you type in is blank is equal to, that's a prompt for Excel, is blank, and you mark the array. And if it is blank, then it'll come as true. If it's not blank, it'll come as false. So you'll see all the, this thing is met, all the 68 values are available. Okay, so likewise, you can test for each of the columns of the data set to ensure there's no missing value. Okay, so these are some of the things which you generally do in your data cleaning. Okay, so next thing is we would like to see what is the demographics. So if you look at the data set, as I said first, one was the demographic, the profile of the respondent, what we have collected. Okay, so generally we deal it separately. So you can collect all that here. So we'd like to know what is the age profile. Okay, we'd like to know what is the gender profile in the head counts. It is the highest qualification count. Okay, so all that is possible on Excel. So generally, when you do this, you can use now these days you have the, if you look at, you go back, sorry, this is coming in between, and just remove it, keep it down. So when you look at, when you go to the home, okay, you got, when you're looking at data analysis, you'll do this, but when you go to home, you have the option of analyze data also, which is prompted by AI. And these days you have a lot of add-ins, okay? So you can actually add in a lot of other, you can add Python coding, you can add Chat GPT, okay? So all this is available, Autopilot, Solver, SAP Cloud, okay? So all these are add-ins which are now available on Excel, and they keep adding. This is the recent one they added. So every 2 weeks, you get things added. So when you say analyze data, okay, so automatically Excel will prompt a lot of these, which is there. So you see age by, cross-section of age by the highest qualification. Okay, it can give you insights on count of awareness, okay, versus the age group. So likewise, it gives. So anything else specific you wanted, you can type it in that. Okay, so this is one of the ways. So generally, when you do that, when you look at age, so the count of age is total was 68. So in this ranges, it was arranged. Okay, so once I get this, I can mark the graph. I'll ask for insert graph. So I can get the visualization. So generally recommended graphs are there. So you can use whichever. So other options you can test in case, and then say yes. So you'll get the options here. So basically 4 branches of it. Okay. So then what you do is you'll check, you can code this as 1, 2, 3, 4. Okay. Why the coding is required is because it's a range. The problem is statistical inferences or descriptive statistics. You require unique numbers. Okay, so you code this. This is the way you code. So it basically says this is the first, second, third, fourth. Okay, so that's the range. And obviously I can code it based on that. So how do I code? So very easy is you can have a filter like this and you can select. So you basically got 3 or 4. So what you do is 18 to 25, wherever it is marked, you call it as 1 and so on. And you keep it doing it. Or you can also do this. You can sort. Okay, so when you sort, it will go to all the 18s together so that you got as 1 and so on. Okay, so whichever ways you think and is up for you, you can do. So once this is done, then what I do is once I have the coding, I can go for the descriptive analytics. Okay, so I have data, I have data analytics. So descriptive analytics, say okay. So I need to mark the array. So I mark this. So make sure that if it is including right from the top or not, you mark it properly. Okay. Then it will ask you where you want your, so enter. So that's done. And make sure you have the $sign. Okay. And then where you want it. So fundamentally, I can, let's say here, I mark yes. Okay. And you want the summary statistics, confidence level for mean, kth values, smaller, and this is 95%. Okay. And say okay. So once you do this, you'll get a output similar to this. So it'll give you the mean, standard error, median, mode, and the highest small, we already know 1 to 4. So count. Okay. So some of this will not have any meaning for you right at the beginning, but the mean is, as I said, is very important because I would like to see what is the mean of the age group. Okay. So let's say I were to take some policy decisions, or I were to see whether I have addressed or used proper network to get the respondents. So you see here, so generally the count of age, that should be equal. Okay, but it's not. So there seems to be a bias in this up till this area. So that's what is the mean. So 2.25. So it's somewhere in between these two. So that means it's going into halfway and part of this. Okay, so it's almost like 60% is in this age group. So we're not covering adequately this. So what it means is when you look at the data set, okay, so if this was the data which has been collected, so it's on blockchain. Okay, so I know that I have not covered the old people. So maybe the decision makers would be at the higher level. So that age has not got covered. So probably it's a totally what you call one-sided kind of survey. Okay, these are some of the conclusions you can draw. So next time, or that's the limitation. Maybe it's because of your network. You're not being able to cover the age group properly. So I would have preferred all the 4 would have been in this age group. So maybe less here is fine because these people may not know what's a blockchain and that techniques. So more so in this range. So I would have preferred here, the crowding here rather than here. Okay, so these are some of the conclusions which I can draw. So I can know that next time I should be able to take a much broader network or look at senior people for getting inference on this topic, whatever your topic is. Okay. So similarly, you can get insights on your gender. Okay, so what's the count? So here again, it's lopsided. So preferably it should be equal. It's not. Okay, so things like that you can infer. So this is very genuine and a concern which generally happens to most of the surveys done. Okay, so these are some of the limitations you should take care of and talk about. So I just come back and take some questions and then proceed. So any questions at this stage? Because I'm just following from practical point of view, this is what we'll require in your DBA or MBA or any survey, what you do, or primary data collection, you will be faced with this, what do you call as emphasis. So that's why I'm just taking. So any concern, anything you would like to know up till now? So we have covered a little bit on what is the age group. We have seen why coding is important, because Excel cannot decipher the text. Okay. So these are some of the things you should consider. And obviously you should also see that it's at the survey level itself, you should look at what kind of data you're collecting, and obviously also who are the people you're approaching, because that will affect your survey inference and the insights. So any questions at this stage? Because see, generally all of you will be doing this survey are already done, but people get stuck right at the beginning because people don't pay attention to these small things, and then later on it shows, because when you go for the Viva, a smart examiner can easily see through what you have done. and ask the right questions. So unless you are quite sure and have done it, all this has been thought of. These are some of the baby steps you need to understand when you do a survey. Otherwise, also when you're a professional, you do a survey for your workplace. These are some of the things which you should take care of. So any questions at this stage? No?
Most of them has said all clear, thanks. Nancy has said.
Okay.
Dr. Mania has
Okay.
said none for me. And
Okay.
Fik has said none so far.
Okay, good.
Uh,
Because
and
what
then,
happens is things like missing data is very important. What happens is when you're collecting, let's say 400 data, and you're not made sure that all the participants need to check on all the boxes. The chances are you'll get quite a sizable amount where the missing data is there, and that will affect your output, the performance. Someone raised the hand?
raise the hand.
I think so.
Where? I'm not seeing, Dr. Shankar, any
No?
hands.
Okay, so we can proceed. Okay. So no
Yeah.
questions at this stage. That's good. Okay.
Yeah.
So I'm going very slow and also doing it very
Yeah, that's
practical
good.
base. Okay. Because
Yeah,
these are some of the things generally people are worried and they come out and get stuck. Okay. So this is the second
Yeah.
thing. So when you do this, so we'd also like to know the age group, and you can have a cross, like in some cases here it may not be so relevant, but you can have uh, how many males versus in what gender, okay, things like that. So that can be easily managed by the analytics here, as I showed you earlier. Okay. So if you use the analytics, it can give you, so here, if I say, let's say I'm bringing the age also and put it here. So a lot of inference can happen. So sometimes it becomes important to note that. Suppose you have these two and say analyze. So it's prompting up. So this is only the count of age. So you can say age and gender. Okay. So it can give you a lot of suggestions. If you go down. Okay, percentage distribution of age, how many different age are there? Or you can say gender-wise age distribution. Okay, so I'm physically showing you all that. So here, when you insert graph, it will go to a new one. So age and the distribution of age and the gender can also be a part of this. Okay, so going back to the next thing, what I would like to do is the count of the highest qualification which I had that. Okay, so this gives me a spreadsheet here. So again, I know who are the people who I've dealt with. Okay, so you'll see the doctorates is 17, high school is 4. So majorly masters and the undergraduate. Okay, so 13 plus 17 is a good number. 50 out of 68 is a good number to be, especially in the research area. So you can talk about some inference there. Okay. So next is based on this conceptual model is what I had collected the data and it has got sent. Okay. So I have done part of the analysis of the demographics as I showed. You can do across the demographics. You can see how many females are having doctorate, for example. So those kind of analysis you can bring out. Okay. So it makes a lot of sense is because let's say you're a university and you're going for a blockchain. So you'd like to know who you'd like to target. So if you find that the females are having more number of doctorate, So your target, you can say, okay, these are the guys I would like to target on, and so on. So a lot of inferences, as I said, data always speaks something. So it is totally depending on the perceiver or the guy who's looking at the data to see what it's communicating. Okay, and it's totally on your understanding. So let's say I have coded data. Okay, so what I've done is basically the original data set. It'll come like this, as I said. So up till here was your, okay. So up till here was your profile questions. So henceforth, from H onward, it's all your, what do you call, the Likert scale, which has got done. So I just copy that. Okay. So once I copy that, then I need to code it. So generally we start with a negative code of disagree to, what do you call as, strongly disagree. Disagree is 2, and 3 is your neutral, 4 is agree, and 5 is strongly agree. Okay, and then we give the coding starting from the most negative to the positive. And when you can do it in a lot of methods, you can, when you say disagree, you can just copy this, find and replace. So disagree was, what do you call as 2. Okay, and replace it. So that's one method of doing it. So you get coded, or you can have a filter and then do it crosswise one by one. Okay, and so ultimately, once if you're done with that, you'll get the coding of the sheet like this. Okay, where it's all coded, and the top, this thing is also coded as per the, what we have used here, the data set. So you'll see here. So this is the code which has been used, and that's the code right in your survey you'll also put. And that is what is coming as the export to your, document. Okay, so that's why I said right at the beginning, whatever you do, make sure that, you're doing it properly. Otherwise, you can end up with a lot of problems. The coding will not match or any of these stuff. So when I got a Likert scale coding like this, so what is that I can look at or infer? Now, what happens is, obviously, the conceptual model is like this. So all in this main, theme of blockchain features and benefits, I got decentralization, immutability, minting, faster, settlement, security. So 5 of it, and so on. Okay. So it depends on how you set it. And these are the various variables which are going into that. So each of them has got scaled, and that is what the coded data is. So for the first one, I got 8, and the second variable is, 8, and the third variable, which is the dependent variable. So if you understand the hypothesis setting, basically the successful, implementation is the outcome. So this we call is as the, dependent variable, because this is depending on the, features of the technology and the higher education needs. Okay, so these two guys are independent variable, and this is the dependent variable. So that's how we have coded it, right, one behind the other. Okay, so once this is ready, so I can do a lot of, calculations and a lot of things on this. Okay, so let's say I want to do a correlation. Okay, so correlation is, I would like to know how this is behaving with this, for example, or how this is behaving with this, and so on. So technically speaking, there are, let's say, how many cells? 1, 2, 3, that is 8 here. 16 and another 8. So 24. So I can have correlation. Every one will have with the other 23. So 24 into 23 combinations are possible. Okay. Of correlation, how one variable is correlating with the other. So what happens is when you're trying to do it on one-to-one basis, it becomes quite cumbersome. Okay. So what we do for the first instant or the first insight, so I take the average of all the first ones. So average is as any is equal to average and just mark the array, and then I can just pull it down and that's done. So next 8. So basically I'm looking at the averages of all the main variables. Okay. And then I have the output. Okay. So when I have this, so this is one type of correlation which I can do. Okay. So I bring out all the averages together, and this is the correlation I have. Okay. So I can, how do I do the correlation? Is let's say one at a time, this with this, this with this, and this with this. Okay. So basically it is coming from correlation. So data analytics. Okay. So I use Pearson correlation here. Okay. So it will ask me for the input range. So let's say I'm doing the first two. I mark the first two together, and it has to be necessarily next to each other. Okay. So, and then say this automatically will take, if we are marking along with the tables, you can do where you want the output, you can do. So you'll see the correlation will come like this. So it is 0.88 or 0.9. So that's a very good correlation. So we know correlation is generally between -1 to +1. So if it can be negatively correlated to variables, at the same time, it can be positively correlated. And when it's not correlated, it's a perfect 0. Okay. So if it's weakly correlated, it comes between, generally as a thumb rule, we look at anything between 0.25 to minus 0.25 as a weak correlation. And what you call a better correlation between 0.25 to 5 on both sides of the scale is a okay correlation we can consider. But anything beyond 0.5 is a very strong correlation. So here, when you see this, it's a very strong correlation between the first variable and the second variable. Okay. Same thing I've done between the second and the third. It's a very strong correlation. And between this and the next, it's again a very strong correlation. So as I said, these two can be marked, these two can be marked. So here I need to bring it here to mark, and I get the correlation. Okay. So technically speaking, this is the way I can look at it. So there are correlation with each other. So when I mark it, there are 3 to 3 matrix. So with the same thing, it is 1, obviously. Okay, the other two are 0.9 and 0.71, which we just saw. So center one again, so it's 0.9 and 1. This is this and this is same, so 1. So these are the correlation with each other. That is with themselves, it's coming as 1. Rest all is valid. So that's what is shown here as a graph. Okay, so this is the first thing what you can look at the correlation. So you know that how correlated these variables are with each other, and that will determine the hypothesis you have set. So if it comes as a very, very low correlation, you know that it is probably coming out because the people see you have this hypothesis and this is what you're trying to test. So you'd like to do it by consensus, by using the survey, or by using the expert interviews. Okay. So 2 ways of doing it. So here we are discussing the quantitative. So these are the themes and I have done this survey. So I collected the consensus, and this consensus shows that the respondents are agreeing to this relationship because the relationship is strong. So that means the hypothesis and the model holds. Okay, so that's the first site inferences. Okay, now what happens is obviously the best way to test it each against again. So as I said, you have 25 into 24 or 24 into 23 correlations which are possible. Okay, so that's what you need to do one by one. Okay, and this is a summary of that. So once you have the whole summary, then I can sit and draw conclusions. Okay, so I can see which are the ones. Okay, so you take a Kesari root generally, so you'll see anything less than 0.5. So we know, or you can say is equal to if less than 0.5, and it can show here most of it is on the higher side. Okay, definitely more than the 0.25. So it's got a very strong correlation, which each variable with the other. Okay, somewhere it is 0.46. So this is between the sixth variable here and the output variable 2. Okay, so some of it will come. So you can sort it out by Excel using the if button. Okay, what if analysis can be done here, and you can solve that. So this will give you an idea of whether the correlation, that is what we call as beta value, is good between the various variables. Okay, here, and this is not capable of handling it all at the same time, because there are softwares which, especially if you have, let's say, SPSS with AMOS, can handle cross variations or cross loading together. You can have Adenco, which can also give you that. And similarly, you can also have PLS, smart PLS, which can give you that same inferences. Okay. So only thing, this is the first idea to see all this is correlated. Okay. So any questions at this time? Because I'm going very slow. I don't want to overload you. This is something pretty heavy. So any questions with the correlation? Because this is mandatory to test any statistical correlation, is how the variables are doing with each other. Any questions? Hello?
We can't see any questions in the chat box. However, any students, if you have any questions, you can unmute your mic and you can ask.
Hi, Dr. Shankar.
Yes, correct.
So based on the amount of knowledge we're gonna analyze, do you think Excel is more than enough, or do we need SPSS, which is gonna make
Excel will give you the first inferences, first insights. Because if it's less than 0.25, you know in the first thing that this is not going to work, or these variables are not coming as per your what do you call initial nudge. Okay, so you need to probably look at it again. And also you can also add some more samples to see whether it's in a positive way. Or if you are doing a mixed method, then you try to bolster it with your interviews, making sure that these weak correlations are handled. Okay,
No.
and definitely you can do it one step. I'm not saying that Excel is sufficient to handle the whole thing. That's why I said that Excel can give you the correlation and the regression. So that's the first stage for you to draw some insight. Because this is the same thing when you use any software like SPSS, or you're going to use Adenco, or you're going to use your Peerless. They're also using the same things. They will first do the correlation, then do the regression. Only thing that's not given as an output. And then based on this, they go further. You're seeing the point.
Yes,
It's the same. The background ops is the same.
no, I mean, so now Excel is enough for the whole process and getting out the output, or do we need the membership for SPSS?
That's what I'm saying. The first insights is good enough with Excel. You can write quite a bit with this. Just now I showed you because that's a correlation showing across.
Yes.
Okay. So all the correlations. So obviously this is coded, right? So once you go back, let's say you're testing something on stock. Okay. So you know oil stock price is one. And the second thing is the market forces, let's say conflict. So you know whether it's correlated or not, whether the guys who are responding to you are agreeing to this aspect or not. That will
Okay.
be very clear in the first correlation itself. That's the beta value. Okay. Any advanced analysis, you can wait and do it later. Okay. So that could be on SPSS. SPSS again will be SPSS not much different from Excel. It's just one stage ahead. Okay, it will give you the same inference, but it will require SPSS with AMOS. That will give you one variable against many other variables at the same time, the cross-loading. You're getting it? Whether the one variable is partly loading with the other and partly with the third. These kind of combinations can be worked with the SPSS AMOS together as add-in, or you can go to your add-in core and peerless.
So I mean, like 5 variables is gonna give Excel can cover and give me the correlation, and no need for SPSS in this case.
Yeah. In the first insight, you will not require much
Okay.
for the first instance.
And there is like a cheap version in SPSS, or it's we have
It's actually very cheap. It's not much. About $80. That's it.
okay. Thank you.
Yeah. Any other questions? Hello? Guys, so in your inferences, have you reached this stage, or any case you'll be reaching this stage? So that's why I'm warning you before. What are the things you need to look at very closely? Okay, whether you're a MBA student or a DBA or a undergrad, if you're doing any research, all this will matter. So these are the things you need to closely watch and think of. So any questions at this stage? No? So you can carry on the next. Simi, are there any questions? Can. Okay.
You may please proceed, Doctor.
Okay. Okay, so it'll look like this, the correlations. Okay. So once you have done this, then the next stage is the regression, basically. So what we do is, again, the regression, we use the averages of the three to do any regression. Okay. So once you have the array, generally we do the data analysis and we can do the regression. Say, okay. So basically a regression is we're trying to see what is a trend. Okay. So it can show the trend once one against the other variable. So that's what we are trying to see. So if we all know the regression analysis, okay, so it generally comes in the type of y is equal to mx plus c. So here we have two variables looking at the other one, okay. So obviously this is the, as I described it earlier, this is your dependent variable and these are independent variables. So that's exactly what I'm writing here. So I'm saying SAF average, this one, okay, is the dependent variable and x1 is this and x2 is this, which are the independent variable. So what it means is, looking at the conceptual model, we're seeing that these two guys are going to determine this output, and that's what it's shown there in the regression. Okay. So I need to, the input, I need to mark, I should be aware of what I'm going to mark, because y is the dependent variable. So I'm going to mark this. Say okay. Okay, and then the input is basically both these guys together. Okay. And I have not used the labels. So confidence level, you can mark 95% ticket. Okay, I want output on the same sheet. So all these graphs you need to mark, because they show very clearly what is the way they are disposed against each other, and say okay. So once you do that, you will get output like this. This is the output you will get. Okay. So it gives you F value, significance of S, F, the P values, you'll see. So if you note very closely, the P values for these two are less than 0.05. So that very clearly shows that the strength of this connection or relationship with the other is very strong, which also can be informed from the correlation. Okay. So this is the basis of Konak, what do you call as a Kroback alpha variation, which is given in your as a validation for SPSS also you'll get, or in the higher softwares. Okay. So from here itself, we can clearly see that these two values, P values, are very low, less than 0.5. Okay, or less than 5% the confidence level, and that is why it is there. So here the intercept is basically the C value, the C here. Okay, so I write the equation now. This is the SIF average. This is this dependent variable is, this is the intercept 0.327 multiplied by the first value x1. Okay, plus 0.324, the second variable. Okay, plus 1.14, which is the intercept. Okay, and that is very much, that's the equation of the total line, and that's very much represented here. So you will see the line going up like this, and this is the probability plot. Okay, so this inference shows you that very clearly that the model is good and can be accepted. Okay. So next is the hypothesis testing, which we call as the test I would like to do. So hypothesis testing is, I can do hypothesis testing on the means, how they are disposed with each other. So we have these three means. So there's no significant difference. That's the HO or the null hypothesis. There's no significant difference in the mean values of the first and the second, or the first and the last one. Okay. And there's a significant difference in the mean values of that's the alternate hypothesis. Then I go for performing the t-test of two samples. Okay. So I can do that on the data analytics screen. So data analytics. So I use the t-tests with equal variances and say okay. So it gives me the two variables I mark, what I mentioned there. So I mark this one, the first one, and drag it down and say S, and then the second one and mark it. So labels alpha value is 0.05. I can keep the output in the same sheet and say okay. Okay, so you'll get these values here. So which shows that how it's correlated to this. So it shows with the p-value. Okay, so p-value is more than 0.05. Okay, so a two sample t-test equal variances were conducted to compare the means of the first variable and the dependent variable. The extremely high p-value of this and the t statistics far below the critical t statistics was this. It's very less. Okay. So confirm that there is no statistical difference, significant difference between the mean values of the first variable and the second variable. Thus, the null hypothesis cannot be rejected. So we accept this. So what we say is we cannot be rejected means it's more or less that there is no significant difference in the mean values of these two variables. Okay. So likewise, you can do alternatives and find out what's the hypothesis of. So as you said that also from your correlation and from your regression line, you can easily make out how the hypotheses are disposed with each other. Okay. And that shows that, as I said, the model is well determined and it's a strong correlation between all the hypotheses. That's what we said that. Okay. So basically, when you look at the independent variable correlation with the SIF average. So these are the things. So the correlation is high. Okay. So the p-value is low and the significance is less than p. P is less than 0.05. So the conclusion is the hypothesis, the interpretation of this is okay. So you're saying that in the bivariant correlation output, look at the Pearson correlation. There is a two-tailed test, significant value. The P is less than indicates a strong correlation. So in the regression output, in the coefficients table, look at the significant values of the first and the second. And if the significance is less than 0.05, the independent variable significantly predicts the final, okay, the dependent variable. So also view the R-squared value to understand how much variance in SAF is explained by the predecessors. So we've seen that also how much is the R-squared. Okay, so you can see the variance and the pool in the R-squared and determine that. So R-squared is 0.533, which says that almost more than 53% of the output is explained by this, okay, by the graph. So that shows a very good, very high R-squared. And that also adds to the validity and the disposition of the variables in the conceptual model, which we initially formulated. And that confirms the whole setup. Okay. So this is purely on the basis of Excel and not using any of the other softwares. Okay. Of course, you can use other softwares like SPSS and the, what you call as the Adenco, as well as the other. So you get the output like this, which I already shown. Okay. So you can also do an ANOVA test based on the hypothesis for the relationship. So only thing you need to segregate it, how the relation is high, low. Okay. So this involves a little bit of complex analysis. So which is not immediately, but we can do it. That's what I've shown you here. It can be done, but it requires a little bit more understanding of the statistics to evolve into that. So which I don't want to confuse you with. Okay. So any questions? So you can test a relationship by looking at the p values and the f values and the t values. Yes, please. Any question?
There's
Yeah,
someone, yeah, School of Business. Please
yeah.
ask.
This is Daniel Thompson from the DBA. Sorry, I cannot change the name. But you are, I don't know whether you said it mistakenly. You said that we accepted the null hypothesis. And my little understanding of stats that we were doing a type 2 test, a type 1 error test. And so
Yes.
will it not be that we do not reject the null hypothesis rather than
That's why
say
I
yes?
worded it. That's why I worded it. It's not rejected.
Okay.
So wording is, you have to be careful, but we cannot say it is accepted. So we say it's,
Correct.
yeah,
Do not.
that's true. That's true. Yeah, that's true. But this can be tested in the higher software. That's not an issue. This is the basic understanding to understand whether your correlations and the regression and the hypothesis are what do you call, matching with your first initial formulation. Does that answer your question?
Yes, it does.
Okay. So any other question? Because most of all the other softwares will be basically working on this. Okay, so I will also be showing later on how to do it on the others, so you can easily see what's the difference. For example, here we were struggling to see one-to-one. Okay, so if you're doing one-to-one, it will take you a lot of time. So plus the overload, cross-loading is not shown there very clearly. Okay, but if I go into
Any other question, guys?
yeah, please ask your questions.
Yeah, if you have any questions, please ask us. Okay, so that you can be clear of if any doubts you are having. Otherwise, we can go ahead.
No questions?
Any questions, guys? I don't think Dr. Shankar, they are having any question.
Oh, no, it's the first time, for me, saying it's the first time for
Okay.
me
Yeah, because
seeing all of this.
they not handle the data till now. But this is something similar. You're working at the workplace. You can do all this in your workplace. Like, for example, let's say you're in HR, for example. So you want to test or make sure that how the work-life balance is working for the employee. So you look at what are the variables of the work balance, and then that you can test each one like this by collecting the data. Of course, you do a Likert scale test, and this is how you do. So it's very imperative for you to just don't do it as a thesis, but look at it from your work point of view and what is the emphasis of each of these at your workplace. It has got a lot to do at your workplace for yourself itself. What are the various variables which would determine whether you're happy with your work. Okay, it could be the environment, it could be your neighbor, it could be anything. So all that you put it as this thing and try to answer it. And the same thing you can build into a test and check out. So it will very statistically, it will show very objectively what is the score, whether it's connected or not. So that's what I was trying to show you. So if you put the same thing on Adenco, for example, let me check. I have the. So it'll be interesting for you to see that, how it works. Okay. So let me check and then I will share. Just let me retrieve the file for myself. Just give me a second. In the meanwhile, if you have any questions.
Yeah. So I think that's very good.
Because by this, if you handle data, you will definitely have a lot of questions. I'm surprised. Yeah. Otherwise, there are only two things, whether you're already doing it properly or you're not started.
The purpose of the study, of course, is very interesting even for the workplace, but the challenge comes in the statistics itself or the calculation process. That's why maybe we need like a econometristic course or statistics course.
Yes, but that's what we already had. No, we had a research methodology course. Right, the first two terms. That's what I think. Dr. Abhijit?
Yeah. Because the second module itself is a research methodology and methods. We got 11 lectures on that, 11 units. So it's a very, stretched module, and it covers the entire spectrum of research methodology and methods. So that
So
is
all
there.
this is, yeah, all this should have got covered by that.
Yeah, this is covered, but then this workshop has been meant to give you more
Just as a
practical
revision,
insights.
yeah.
Yeah,
Revision
drilling
and
down.
also,
Yeah,
yeah.
revision. Yes, yes. So that's what is helping you to understand quantitative aspect of the research very well, and that's why the purpose of this workshop. So try to get it and try to practice it, because in quantitative area, unless you practice it, you can't master it, or you can't get that much used to it. So better you practice it, what Dr. Shankar is showing and telling. Try to do that, and I'm sure you will be able to. And there are loads of tutorials. You see, Simi has already forwarded you many tutorials. So please go through that. And this workshop is also recorded. So if you are trying to, if you have forgotten something which has been spoken here, or which has been instructed by Dr. Shankar over here, so please go through this again. Okay, and go frame by frame and understand if some point you are missing. But practice is most important thing. So whatever may be the class, whatever may be our efforts to drill it down to you, so that you can understand and apply. But it depends on you how you are practicing it. So try to, and any basic statistics book will also help you. Any basic statistics book, that will also help you. But this particular workshop is helping where the basic statistics book will not help, to do it practically. The spreadsheet, okay, what Dr. Shankar has shown, how to align data, how to manipulate data, how to manage the data. Okay, that's very important. And then the how to apply formula that has been given, how to filter the data, that is also Dr. Shankar has shown. Okay, so please understand that to apply, and if you need to revisit, you can revisit this understanding again by going through this recorded version of this workshop and the previous workshop of Dr. Shankar, part 1 and part 2. And Simi is here, so I can request Simi to send the video link, recording link of part 1 and part 2 to all of you, so that you guys understand and go through that and understand, okay, what Dr. Shankar is instructing you. Yeah, thank you, Simi. So that's how it will be done, and we will share this also with the other module as well. Okay.
So I'm not still finished. I'll just do one more model for them.
Yeah, please
Yeah,
go
so-
ahead. Please go ahead. I'm
because
just
that
giving
will-
them
yeah.
that how to get conversant with what you are teaching
Yeah.
today, training them. So it is a more of a training, guys, not a teaching. It's more of a training. So try to use it practically. Okay. All the best. Over to Dr. Shankar.
So if I'm importing data like this, so let's say already have it here once. Okay. Yes, you can close this one. So on a sheet, it could look like this. So I'm not on. Let's see. Then go. So when I'm importing the whole thing, let's say I'm importing it to a software like SPSS. Okay. So I can open the file here. So let's see whether I've saved it. So I can import data from Excel. The coded sheet what we had, if you remember, the same thing I can open it here. It's all empty one. We get the right sheet. Okay. So you see that it is asking whether what I have to do with this missing value in case there's a missing value. Okay, and I can finish. So even it's capable of assuming certain values. Okay, once you determine it. So you'll see that when I'm pushing the values here. So it's already handling the cross variations, what I was describing. So it's very easy for you to. So these are the 8 values which is determining the first constraint. So that is BCF, BCTF. Okay. Sorry. So I'm just showing you how it will look. Okay. It's the same thing as what we had done in the Excel. So we got 3 variables. So I need to push all the variables in and then study how it looks. So there's a backups is the same Excel what I told you about and how it handles it. So it's not much different, but this is far more easier and more flexible. So this is the output I have. So it's already working out the correlation. So if we test the correlations against each of this, what you had done earlier, so you'll see it'll all match. Okay. So now I want to test the hypothesis. So that's the first correlation I got. This is also pretty high. This is also high. Okay, so 0.613, that's similar to what we have done earlier. So once you have this thing, you can run the tests because we have 68 values. It will run with 5,000 values. It's a bootstrap. Okay, use bootstrapping, access model, save and run. It takes a few minutes and it gives you the full output. Okay, so that's the output. It will come as an export or directly I can do it on the HTML. Okay, I can do that. Or I can view the results, show results directly on the, okay. So once you run this, you'll see the correlation. Okay, this is a 3-star. We'll see the model fit. It will show the construct reliability the convex alpha is all above 0.9. Okay. So all this is, and then the correlation between each of these, this is what we saw there. And the indicator reliability tests on the Excel, you remember, that's the same thing. So it is showing for all the values and the cross-loading one against the other. Okay, that will all come. And that's the whole result. So this is in depth, it will show exactly whatever you want. Okay. So similarly, if you're looking at, let's say, some other model, okay. So let's say this is a data sheet I've collected. So these are two Likert scales, 2 and 3. 3 of these variables linked to the output. Okay, so if you look at the conceptual model here, let's say using AI in education, this is the output, that is a dependent variable, independent variable, independent variable, and each of these have got 2 codings, and this is the output from my Google form. Okay, so same ways I proceed with the age analysis. So I do the statistical analysis. I can do the frequency of age. I can also look at the box and whisker. So it shows if there are any outliners. So if I'm going to make any policies, I'll stick to the age group of this, and this is outside. So they will not, it also shows that the normality is quite high. So it's valid in that sense, because most of the values are coupled around the mean inside the, what you call as 1 sigma. Okay, this is the distribution of the count. So these are some of the things which you can readily do for your demographic. Let's say for the gender, okay, so this is a count. So I can check on how many people were done. So 71, so males 36, 24, and others are they basically not want to mention or whatever is the output of that. So education levels, similar graph. Statistics I can look at, hypothesis testing. Okay. So we can use the two-tailed tests. So basically, the hypothesis testing for Excel, you can do it on 3 of this, okay? So you can aspect is, let's say you can do the t-test, you can do the ANOVA, you can do a chi-test. So what is the purpose is, this is done when you compare means between 2 groups, like how we form the means and then I compared, then I can do the t-test there. Compare means among 3 or more groups. So here there are 3 outputs, so I can compare those means using the ANOVA, and the Chaikovsky test is test for association between the categorical variables. So data type continuous. So this is something you need to understand. So when I do the test, the null hypothesis means of 2 groups are equal. All group means are equal. Variables are independent, no association for a chi-square test because they belong to different categories. Okay. So this is the testing guidelines which you will use. So let's say I am going to have this data tested. Okay. So what I've done is basically I have done the test on there's no statistical difference between the means. So, and I done that two-tailed test or a t-test. Okay, and found out this. This is similar to what I taught earlier. Okay, so age group, since it's a different this thing, I can use the ANOVA tests. Okay, so there's no major influence of age on the education level. So there's a major influence of age on the education level. So I can use that. And this is the box plot for graduate, undergraduate, and postgraduate. Okay, so based on this, I do the tests using the means. Okay, so F is 0.64, p-value is more than 0.05. So I basically reject the null hypothesis, or we fail to reject the null hypothesis because it's more than this. Okay, so there is no statistical significant difference in the mean age group across the various education levels. Thus, age does not have a major, what do you call, as influence on the output. Okay. So similarly, for your, you use the means as coded, then you do the correlation as we seen here. And then we do the regression. That will give you the whole. So you see how they are correlated, and depending on the F value, which is quite high, significant F is much less. So that's why it is a robust model. Okay, R squared is explained only 18%. So in that sense, it is not all the variables are equally there. So if you look at the variable 1, 2, 3, so p value here, the first one is not significant. Okay, so second and third, that's why you're getting the R squared quite low. A good R squared should be more than 25%. So these are the things which are practically, you can do it on the Excel. So which is very surprising because a lot of people don't see it like that. So you see
Question.
the, yes, please.
You said a good R squared is anything above 25%.
That's a good,
Is that a general rule, or would it depend on the type of relationship we are
it
addressing?
depends a lot on the relationship, of course. But here, what it means is when you have a R square, it explains that this model is able to explain 25% of the variables. Okay, so in that sense, it is not very high. Okay, but it's still able to explain almost 1/4 of the model. That's what it means. But of course, anything less than that is too low to consider for a good model. Does that explain you?
Yes.
Okay, so it depends on what type of, see, if let's say you're looking something at social science, okay, a topic like that, which is very subjective, and then you get it on a survey. What happens is most of the guys who are taking the survey are not knowledgeable. So they may not understand your questions, or they're not able to comprehend the hypothesis you are set. So that could be one of the reasons why it's not. So that's why we try to use the qualitative as well as the quantitative. Okay. Because when you're doing the qualitative, you're looking at the experts, they will be more or less able to explain the intricacies and answer your questions. So then you see that, let's say you have 3 or 4 hypotheses. So in a lot of cases, you will see 1 or 2 hypotheses which are rejected using the statistics because the stakeholders are not so knowledgeable. Whereas the same thing gets confirmed on the qualitative in the interviews because those guys are knowledgeable and they have the expertise in that. So then you say that these are the exact ways, and then you triangulate saying that since it is supported in the qualitative, we can accept it. Okay. Or you want to reject it also, you can. So you should have a strong knowledge to go about it. That's all. Rest of the
Would
things
I,
is, yeah.
yeah, would I also be correct to say that without a 25% reliability R squared value, that it's still, I would sort of very be cautious in terms of predictability. If I'm predicting like students' grade, if my model is only explaining 25% of
Yeah.
the variation, I would be, I guess that's the qualitative side of it. I would be guided
Yes.
in how I produce
Yes.
students' grades.
Statistically, you are able to only predict 25% of the whole factors. That's what it means. You're right in saying that.
Thank
Whereas
you.
if it's pushed towards 50, then that's a very good, very high inference or
So,
predictability.
so even in our write-up, even though we may say that it is demonstrating high reliability, but we would be cautious in how we
In saying,
produce, how we
yeah,
interpret its production, its forecast or its prediction.
yes, true,
Thank you.
correct. So any more questions? I think I covered 2 models, and I also showed you how to use a software for that. So basically at this stage, if we are not done any survey, it will not mean much, but you should at least know that these are the things you can achieve or you need to do in your thesis. Because whether it's a MBA thesis or a bachelor's thesis, these are some of the things you can easily infer and get out of insights for your primary data collected. And that's very imperative for you to know, especially if you have a quality of the conceptual model, the themes are very clear. So it will also help you. The same themes are going to be used for your interview questions. So you, any software, even the NVO or any of this thing is already, you have the themes done, you have the coding done already. So you just have to fill in the transcript and just carry on and do that output. So fundamentally, I suggest all of you should go for the conceptual model, exploring the hypothesis. That's the best way forward. And of course, use the mixed method since you got time. So if it's a squeezed semester or a small time, this obviously you're going to look at one. One of these or a mono method is more to be used. So that's also possible. So given a choice between these two, depending on your topic, if it's something on the mental makeup or psychology part, I will go for the interviews. If it's a free flow, stick with the survey. And of course, both of them together is the best, but depending on the time frame. So any questions? I'm done now. So we'll share the Excel sheet and you have the recording. So anything else you can always get back. So maybe at a later stage when you repeat these kind of, maybe have another session, then it will be more meaningful. Yes, Dr. Dewald, do you want to say something? Since Abhijit is not there. So Dewald, do you want to add something? Or we can call it a... Okay, Simi. So we're done for the day.
Okay. And any researcher who wants to add anything or any questions that you want to ask, you may unmute your mic and you can ask.
There's
Yeah,
something on the
can
chat, I
I
think.
ask one question, please?
Yes, please. Dalia.
Yeah. If in my survey I have added two variables in one questions, how I can make the correlation?
You have two variables in the main
In
variable.
one question, يعني, my thesis is talking about the implication of cost, delays, and waste on life cycle project, biomedical research life cycle.
So you can
So
consider them as two different sub variables, and those two
yeah,
sub
yeah,
variables will make a
but
main
in
variable.
one question, I combine to ask the participant the implication of the waste and cost, for example, in one question.
It will be difficult because that's why you have to be careful in splitting it up.
Yeah, I didn't take this. Yani, I just discovered it now when you
So
are doing
what you can do is you can take the average, whatever answer because they are answering two questions in one. So you take that as the average. That's the best you can do.
So, for example, if I'm asking from your past experience and the choices is a strong agree, strong or agree or neutral or disagree or strong disagree, how I can make the correlation now?
Yeah,
This
that's
my
what I'm
question.
saying, that you start with the most negative as 1 and then highest is 5 and you're doing the
but
coding.
up till
Okay.
now every respond is agree, yani it's post implication.
Then it should lead to a good correlation because everyone is agreeing to it.
Yeah,
But
but I remember when you make the variables, you make every variables alone.
Yes, so when you do
So
that,
how I will do it in alignment with the hypothesis? This is my question.
yeah, so every hypothesis, like if I may share again one minute.
Okay. Sorry,
If-
doctor, but
Yeah, it's any
it's coming
question.
to my attention and I discover it now.
Yes,
I
you'll
can
require it any
change
day.
the survey.
See once again. When you look at the conceptual model, for example, okay.
Yeah.
Let me go there. This is looking for the data sheet, which has that one. Yeah, here. Let's say there is here. Okay. So now this is under this, you're saying there are two more variables, right?
No. For example, if I will use this as a one variable and the other one, under each one, there is three variables.
Yes. So here, if you see, each one of them has got two variables. So you're coming to a situation like this, right?
Yeah.
So, but then you're not asked the questions separately. You ask them together.
Yeah, because it's
It's
linked.
Yes, I understand. So what you can do is these two, any case, they're clubbed together. You take the mean. The answer what you got, you consider as the mean. So you don't have anything to do with the mean. So this is already done for you.
Okay.
You don't have to do the mean. It's already that single answer is the mean.
Okay.
And
That's
then you
good.
carry forward. Then you carry forward what you do.
Okay.
Okay.
Okay. Because I feel that I make a mistake, but I want to
Yeah,
solve it now.
it should have been pointed out to you by the supervisor right at this stage.
No, I take approval before I set up the survey, unfortunately, but
Yeah, that's
I
what I'm saying.
discover it now.
So it's also the supervisor's mistake. They should have seen it too.
But
It's
this will
okay at this
impact
stage.
the
No,
overall.
it will not. It will not because you're taking the average. That's fine. That's the best thing you can do now. Otherwise, you'll have to repeat your survey.
Oh no, impossible. Because
So you take
يعني
that as it.
والله it's impossible because
So
I'm
that's why
here
I'm
in
saying
Qatar
I'm giving you the
and
solution. So excuse me, I'm
participants.
giving you the solution. So don't get confused. So I'm saying what you get as the answer for two, that's the average.
Okay, average.
Okay. Yeah.
Okay.
Just stick to that.
Okay. Thank you so much, doctor. Thank you.
Okay.
Thank you.
Yes. So anything else to go? Any other
Anybody?
questions?
One last question from any of our researcher, or we can end. Okay, I think there are no questions. Thank you so much, Dr. Shankar, for leading today's workshop. It was
So I'll
truly
send you the
informative.
Excel sheet. I'll send you the PPT and this thing you can forward it to them.
Sure. So we'll be sharing the recordings with all the researchers shortly.
Okay.
Thank you so
Bye-bye.
much. Thank
Thank
you,
you.
researchers.
Thanks.
Thank you.
Thanks.
Bye-bye.